In our Chemical Properties of Monosaccharides podcast, we're going to talk about how monosaccharides can be oxidized and how they can be reduced. And then we're also going to talk about some of the applications of those reactions. Monosaccharides can be oxidized to carboxylic acids. We call these, if they can be oxidized, we call them reducing sugars because they're the agent doing the reducing. And a good example of this is over on your right, D-glucose in the presence of Benedict's reagent is an aldose, so it has an aldehyde. We know aldehydes can go through oxidation reactions to form carboxylic acids, which is what we're seeing on D-gluconic acid. So our aldehyde is oxidized to a carboxylic acid. When this happens, you're going to go from a blue Benedict's reagent to a brick red, and that says brick. It's brick, I promise. You're going to go to a brick red precipitate for that. Aldose and ketose carbonyls can also be reduced to hydroxyl groups. When they're reduced, we call them sugar alcohols. So in order for this to happen, you're going to need a free OH on your anomeric carbon. And an example of this is the reaction that produces sorbitol. So we don't have that reaction down here, but we have one similar. Sorbitol is used in diet drinks or anything that's really considered to be sugar-free, candies and gums. This product down here, the reaction we are seeing, xylitol, is another sweetener that is not considered sucrose, but it's used to sweeten gums specifically. Sorbitol is about 60% as sweet as sucrose. When you hear the term sugar-free, that's kind of a misnomer. What sugar-free really means is that it is sucrose-free. It's not that disaccharide sucrose. So back to our reaction. With a reduction or a hydrogenation reaction, we're going to add H2 in the presence of our catalyst. And we are going to decrease the number of carbon-oxygen bonds, and we are going to increase the number of carbon-hydrogen bonds. So our carbon goes from having one hydrogen bonded to it to two, and that produces our sugar alcohol. All right, so we're going to have to talk for a second about these artificial sweeteners for a moment, because this is probably one of my favorite conversations about why you should be super duper careful in lab. And it also is a surprising testament to how many more chemists have survived lab than should have. All right, so artificial sweeteners have a very funny history. Sucralose, you know it by the trade name Splenda, is an artificial sweetener. We have a table of relative sweetness over here. Sucralose, holy mackerel. The relative sweetness, and I always like to compare it to table sugar. Think of table sugar as being your baseline. Sucralose is 600 times more sweet than sucrose. So if you really want to sweeten something, Splenda's the way to do it. Sucralose was discovered in 1976. There was a chemist working in a lab, and he misunderstood his superior. He thought his superior said to taste the substance he made, when in actuality, the superior asked him to test his compound. So rather than testing the compound, he tasted it and thankfully didn't die, but instead discovered sucralose. All right, aspartame goes by the trade name Equal. This was discovered in 1965. Again, we have a chemist who should not be with us who actually discovered something that was useful. He licked his dirty hands after lab. We know we're supposed to wash hands after lab, but when he licked his dirty hands in lab, he tasted that whatever was on his hands was sweet, and we discovered aspartame. The last molecule that we have for you is saccharin, and it goes by the trade name Sweet and Low. And I know saccharin's gotten a bad rap, but this is one of the oldest artificial sweeteners that we know. It was discovered in 1879 by a chemist who once again failed to wash his hands after working in the lab. Took a bite of a sandwich, noticed his sandwich was really sweet, and put two and two together that this must have come from whatever the heck was still on my hands. So the moral of this story is wash your hands after lab and never put anything in your mouth. Saccharin, because it has such a long history and was a sweetener, was something that was also used during World War I with sugar shortages that we had. So we used saccharin in place of sugar. Also, there is no good research that shows a link to cancer. So you're okay to have saccharin. Like everything in life, moderation is going to do you good. So don't, eat it by the ton. All right, so we can use the oxidation of monosaccharides in order to determine the amount of sugar in urine. Say if you have diabetes and want to know what your blood sugar levels are, we can use an oxidation reaction to do that. And in fact, that's how products like Clinistics or your digital blood glucose meters work. They're going to use an oxidation reaction to do this. So prick your finger to get some blood, and in that blood we expect there to be some amount of glucose if you're living. The glucose is then oxidized. The test strips are going to have glucose oxidase in them, and this is going to cause the oxidation of our aldose. So we're going to wind up with gluconic acid. So we've taken our aldehyde and we've oxidized it to a carboxylic acid. What this also produces is the side product hydrogen peroxide. Hydrogen peroxide is then allowed to react with another substance in these strips. We're talking about the strips right now, not the digital meters. And depending on the intensity of the color that you get or the amount of hydrogen peroxide that's produced, that's going to correlate to the amount of glucose that's in the blood. Modern meters work a little bit different. Your modern meters are going to measure the amount of oxidizing agent that reacts with a known amount of blood. So if you have more glucose in the blood, you're going to require more oxidizing agent. And so therefore you can correlate that value, how much oxidizing agent is used, with the blood glucose levels. If you have an increase in blood glucose levels, you're going to need insulin. If you have a decrease in blood glucose levels, you're going to need to eat some food to bring that level up again.